Hello everyone, welcome to the channel Knowledge for You. Today I am going to tell the most important question of electronic devices subject, unit name, power supplies. This is the second unit. This subject is common for EEE students, EC students, instrumentation branch. So let's start here. The first question is define rectifier. This is one of the important question for 1 mark. So rectifier, it is electronic device that converts alternating current to direct current. So simply, which converts AC to DC is known as rectifier. So rectifier is an electronic device that converts. It's an electronic device that converts alternating current to direct current. That is AC to DC. And the precise definition of rectifier is, it is an electronic device which converts AC to pulsating DC. Okay, so this is the input to the rectifier we are giving AC. This is the rectifier unit we have, and the output of rectifier we are getting pulsating DC. This is the diagram. So it is an electronic device which converts alternating current to the pulsating DC direct current. And the next question is, what are the types of rectifiers? What are the types of rectifiers? This is also important question for 1 mark. The types of rectifiers are, first one, half wave rectifier. The first one, half wave rectifier, and the second one, full wave rectifier. There are 2 types of rectifiers. First one, half wave rectifier. Second one is full wave rectifier. And in full wave rectifier, further, it is of 2 types. The full wave rectifier is of 2 types. The first one is center tapped, and the next one is bridge rectifier. If the question is half of 1 mark, what are the types of rectifier? Then you have to write, this is of 2 types, half wave rectifier and full wave rectifier. If it is for 3 marks, then you have to write, full wave is further classified in 2 types, center tapped, full wave rectifier, and bridge rectifier. So next we have, explain the working and draw the circuit diagrams and waveforms of the half wave rectifier. This question is for 5 marks. This question is for 5 marks. So first, see the definition of half wave rectifier. A half wave rectifier is a rectifier circuit that converts AC voltage to pulsating DC voltage by allowing only 1/2 cycle of the AC input to pass through the load. So once again I am repeating, it is a rectifier circuit that converts, the definition of rectifier is it converts AC to pulsating DC by allowing only 1/2 cycle of the AC input to pass through the load. Allowing only 1/2 cycle of the AC input to pass through the load while blocking the other cycle. So let's see here, what is the meaning of 1/2 cycle means. If it is my alternating current or AC waveform, so this is the input voltage we have, this is the maximum voltage of the sinusoidal waveform Vm. So this is 0, this is 180 degrees pi, this is 2 pi, this is 3 pi. So if I draw the output waveform, then half wave rectifier, it is a rectifier which converts AC to pulsating DC by allowing only 1/2 cycle. This is the half cycle of the AC input waveform, this is the another half cycle. So it allows only 1/2 cycle of the AC input to pass through the load by blocking the other half. That means it does not allow the negative half. It allows only 1/2 cycle of the AC input to pass through the load. And whenever negative half cycle comes, then simply it blocks the negative half. Then we don't get any output voltage in the negative half. And again in the positive half, we get the output like this. So here it is the pulsating DC, which allows only, it converts AC to pulsating DC, which allows only 1/2 cycle of the AC input waveform. So this is the circuit diagram of half wave rectifier. So this is nothing but transformer, primary winding, secondary winding. At the primary winding we are applying the AC voltage, which is nothing but 230 volts AC. So this is the AC input we are applying. So this is the half wave rectifier, means here we use only a single diode, one diode. This is the secondary winding of the transformer. This is the diode arrangement. This is the positive P type and this is the N type. This is a symbol of a diode, and here we have connected a load resistor RL through which the load current IL flows, and across the load resistor nothing but this is the output across which we are measuring the voltage. So this is the resistor, nothing but output across which we are measuring the output voltage. So across the load resistor we measure the output voltage V0. So let's see the operation of the half-wave rectifier. So remember, the diagram of the half-wave rectifier will be asked for 3 marks. Draw the diagram of half-wave rectifier. So this is the diagram of half-wave rectifier. Now let's see the working of this half-wave rectifier. So before that, what is the definition of half-wave rectifier? It is an electronic device which converts AC to pulsating DC by allowing only 1/2 cycle of the AC input to pass to the load. So let us see the working of this particular half-wave rectifier. So here we have this working is explained in 2 cases. The first case is what happens during positive half cycle of the input waveform. So if it is my input waveform, so we are going to see the 2 cases. The first case is positive half cycle case and the second case is negative half cycle case. So during the positive half cycle, what happens means, this is the terminal A, terminal B. This terminal A is connected to positive terminal and this B is connected to negative. So since A is connected to positive, this is a P type, P is also positive, and this negative is connected to N type terminal. Therefore, the diode becomes forward bias. What is the definition of forward bias? If P type is connected to positive terminal and N type is connected to negative terminal of the battery, then it is a forward bias. So during the positive half cycle of the input waveform, the diode will be forward bias, and in forward bias diode behaves like a closed switch. It becomes closed switch. As a result, the current starts flowing through the circuit and through the load. So current flows like this and we can measure the output voltage across it. So this is the working in positive half cycle. Look at here. So during the positive half cycle of the input, the diode becomes forward bias. So in forward bias, the diode conducts the current, nothing but it becomes short circuited, SC, it becomes short circuited and allows the current to flow through it, and the current flows to the load resistance RL and the output is measured across load resistor RL. This is the working in positive half. Now coming to the negative half cycle. During the negative half cycle, what happens? This terminal A becomes negative and terminal B becomes positive. As the diode P terminal is connected to negative, therefore it makes the diode reverse biased. So during the negative half cycle, the diode will be reverse biased, and in reverse bias diode becomes open circuited. In reverse bias diode becomes open circuited and the circuit becomes like this. So here the diode becomes open circuited, and if it is open, the current does not flow through the load resistor. As a result, the output voltage is equals to, what is the formula we have? I into RL. Therefore this current is what? 0 into something 0. So therefore diode does not conduct, it behaves like an open circuit. Therefore no current flows through the load. As a result, output voltage across the load resistor is 0. So therefore in negative waveform or negative half cycle of the AC input, the output voltage is what? 0. Diode does not conduct and becomes reverse biased. As a result, no current flows to the load resistor. Therefore, the output voltage is what? 0. So this is the waveforms we have to draw. This is the output waveform of the half-wave rectifier. Okay, so final conclusion is, thus only half cycle of the AC input is converted to DC. Therefore the definition is, it converts AC waveform to the pulsating DC by allowing only 1/2 cycle of the AC input waveform. So this is the most important question for 5 mark. In the next video we will discuss center tap full wave rectifier and bridge rectifier. Thank you.